1. NASA launches SNIFS rocket, unlocking the Sun's chromosphere secrets. 2. NASA launches rocket for CU Boulder Space Science mission. 3. NASA SNIFS mission, Sun's chromosphere secrets revealed. 1. NASA launches SNIFS rocket, unlocking the Sun's chromosphere secrets. Imagine the Sun's chromosphere as a dynamic, ever-changing region that's crucial to understanding solar activity. This layer, sandwiched between the Sun's visible surface, the photosphere, and its million-degree atmosphere, the corona, is where solar flares, hot plasma jets, and powerful energy fluxes originate. But here's where it gets controversial: the chromosphere's temperature can vary wildly, from a mere 6,000 degrees Celsius to over 1,000,000 degrees Celsius. This makes it a hotbed of scientific curiosity and a challenge to study. On July 18, NASA, in collaboration with an international team of solar physicists, will launch a sounding rocket from New Mexico to delve deeper into this enigmatic region. The mission will carry the Solar EruptioN Integral Field Spectrograph, SNIFS, a cutting-edge instrument designed to capture high-resolution spectroscopic data from both the chromosphere and the transition region in real time. SNIFS is a first-of-its-kind solar instrument, offering a full 2D field of view and a complete spectrum for every pixel, effectively creating a 3D data set for each moment in time. This will allow scientists to calculate temperatures, velocities, and densities of the solar plasma, providing unprecedented insights into the chromosphere's behavior. The instrument comprises a Gregorian-style reflecting telescope combined with a spectrograph via a specialized mirrorlet array, ensuring that light from each spatial location in the image is spectrally dispersed without overlap from neighboring locations. But this is the 2. NASA launches rocket for CU Boulder Space Science mission. Imagine a rocket soaring into the sky, reaching the speed of sound in mere seconds, all to unravel the mysteries of the Sun. This isn't science fiction, it's happening this Friday, and it's about to change our understanding of solar phenomena. On Friday, NASA and the University of Colorado Boulder, CU Boulder, are set to launch a 60-foot sounding rocket from the White Sands Missile Range in New Mexico. The launch, scheduled for 1 p.m. Mountain Daylight Time, is part of a collaborative mission to study the Sun. Sounding rockets, like the one being launched, are designed to carry scientific instruments to space for short-duration research missions, typically lasting about 15 to 20 minutes. These rockets are a cost-effective alternative to larger orbital rockets, which are used for longer-term space exploration. The rocket will carry a single instrument known as the SNIFS payload, or Solar EruptioN Integral Field Spectrograph. This cutting-edge device, developed by scientists, engineers, and students at CU Boulder's Laboratory for Atmospheric and Space Physics, LASP, is a novel UV spectrograph. Unlike traditional spectrographs, the SNIFS can simultaneously capture images of the Sun while separating incoming light by its wavelength. This capability allows researchers to observe and analyze the Sun's activities, such as temperature fluctuations and plasma movements, in unprecedented detail. We can actually use this to inform ourselves of the 3D structure and movement we're looking at on the Sun, explained Vicky Hurd, a former doctoral student on the project who recently graduated from CU Boulder. The entire mission will last approximately 15 minutes, with the rocket reaching an altitude of 150 miles in just a minute and a half. The SNIFS instrument will then spend about 8 minutes collecting data and observing the Sun before the rocket descends back to Earth via parachute, landing in the New Mexico desert. A helicopter will retrieve the rocket for further analysis. For Phil Chamberlain, a senior research associate at LASP, this launch marks a significant milestone. He has been working on the SNIFS instrument for over 4 years and will serve as the principal investigator for the first time. "We've gone through problems, it's been a struggle, it's been a roller coaster, but we're ready," Chamberlain said. Despite the challenges, he remains confident in the mission's success, though he admits to feeling a mix of nerves and excitement. One of the primary goals of the mission is to enhance our understanding of the Sun, particularly focusing on solar spicules, small eruptions in the Sun's chromosphere. The chromosphere is a thin layer of plasma located between the Sun's visible surface and its upper atmosphere, the corona. When spicules erupt, They heat up and move plasma around the sun, potentially contributing to the mysterious phenomenon known as the coronal heating problem. This long-standing puzzle in solar physics asks why the sun's outer atmosphere, the corona, is millions of degrees hotter than the sun's surface. It's like sitting next to a campfire, but the fire gets hotter as you walk away from it, Chamberlain noted. Scientists believe there must be a mechanism at work in the sun that defies conventional thermodynamics, and the CU Boulder team hopes to determine whether spicules play a crucial role in this process. Another objective of the mission is to validate the new spectrograph technology, paving the way for its use in future space missions. Chamberlain aims to demonstrate the effectiveness of the SNIFS instrument to NASA, advocating for a larger, multi-year space mission. We're proving that this tech works and the science is worthwhile on this quick, cheap way of collecting data, via sounding rocket, he explained. The mission also serves as a valuable training ground for the next generation of scientists and aerospace engineers. Approximately 7 to 8 graduate and undergraduate students from CU Boulder, along with about 25 other contributors from LASP, have been involved in the development of the SNIFS instrument. These students are gaining hands-on experience in rocket science and engineering, and they will soon learn how to analyze the data collected during the mission and publish their findings. These students have started learning how to do rocket science, how to be engineers. The next step is that the students are going to learn how to analyze data and write papers, Chamberlain said. Once the rocket returns to Earth, the team will begin processing the data, running it through computer programs, and creating 3D models of the sun and its atmosphere to simulate the observed events. This research is crucial because the sun's activity, including space weather and solar storms, can have significant impacts on Earth, such as disrupting communications, damaging satellites, and posing risks to astronauts. We hope this small contribution will increase our society's ability to model the sun and predict when these dangerous storms are going to happen, Hurt emphasized. If you're eager to witness this groundbreaking launch, you can tune in to the live stream at 1 p.m. Friday via video.ibm.com/WSTF-WSMR. And this is the part most people miss. The real magic happens after the launch, as the data starts to reveal new insights into the sun's behavior. What do you think could be the most surprising discovery from this mission? Share your thoughts in the comments. 3. NASA SNIFS mission, Sun's Chromosphere secrets revealed. NASA is set to embark on an exciting journey with the launch of the Solar EruptioN Integral Field Spectrograph mission, commonly referred to as SNIFS. This innovative mission, scheduled for launch in July, will be propelled into space by a Black Brant IX sounding rocket. Its primary objective is to investigate the energy and dynamics of the chromosphere, a particularly intricate layer of the sun's atmosphere. The launch window for the SNIFS mission will open at the White Sands Missile Range in New Mexico on Friday, July 18. The chromosphere is situated between the sun's visible surface, known as the photosphere, and its outermost layer, the corona. While scientists have conducted extensive research on the various layers of the sun's atmosphere, the chromosphere remains shrouded in mystery, with numerous unanswered questions. There are still many unknowns, remarked Philip Chamberlain, a research scientist at the University of Colorado Boulder and the principal investigator for the SNIFS mission. This mission is particularly significant as it aims to shed light on the processes occurring within the chromosphere, which is crucial for understanding solar phenomena. The chromosphere is not just a passive layer, it plays a vital role in solar activity, including solar flares and coronal mass ejections, which can have profound effects on space weather. These solar eruptions are the primary drivers of space weather, creating hazardous conditions in near-Earth space that can jeopardize satellites and pose risks to astronauts. The SNIFS mission seeks to unravel how energy is transferred and transformed within the chromosphere, ultimately contributing to these massive solar explosions. To ensure the safety of Earth from space weather, we need to develop accurate models, explained Vicky Hurd, a doctoral graduate from CU Boulder who collaborated with Chamberlain on the SNIFS project. The SNIFS mission is groundbreaking as it represents the first solar ultraviolet integral field spectrograph. This advanced technology merges the capabilities of an imager and a spectrograph. Imagers are adept at capturing photos and videos, allowing for a broad view of light from a large area simultaneously. In contrast, spectrographs analyze light by breaking it down into its various wavelengths, revealing the elements present, their temperatures, and their movements, but only from a single point at a time. By combining these two technologies, SNIFS offers a comprehensive tool for solar research. It's the best of both worlds, Chamberlain noted. We are pushing the boundaries of what technology can achieve. Focusing on specific wavelengths, known as spectral lines, the SNIFS mission will provide valuable insights into the chromosphere. These spectral lines include a prominent hydrogen line in the Sun's ultraviolet spectrum, as well as lines from silicon and oxygen. The data collected from these wavelengths will help scientists trace the movement of solar material and energy through the chromosphere, enhancing our understanding of its connection to the upper atmosphere. The SNIFS mission will be launched aboard a sounding rocket, which serves as an effective platform for conducting space experiments. This approach not only facilitates scientific research but also offers invaluable hands-on experience for students and early career researchers. Vicky Hurd, along with her colleagues Joseph Wallace and Gabby Gonzalez, expressed their enthusiasm for the project, highlighting the unique opportunity it provides for students to engage with the hardware directly. "You can really try some wild things," Hurd said. "It allows students to get involved in the practical aspects of space science." Chamberlain emphasized the importance of such missions for nurturing the next generation of scientists, who bring fresh ideas and enthusiasm to the field. The entire SNIFS mission is expected to last approximately 15 minutes, with the sounding rocket taking about 90 seconds to reach space, followed by 7 to 8 minutes of experimentation on the chromosphere, and finally 3 to 5 minutes for the return to Earth. The rocket will drift approximately 70 to 80 miles, 112 to 128 kilometers, from the launch pad before landing, necessitating careful planning to ensure a safe landing site. The White Sands Missile Range, with its vast, open desert, is an ideal location for this mission. Hurd, who dedicated 4 years to the project, expressed her excitement for the upcoming launch, stating, "This has been my baby.